Guys, we'll call this radius 1, 1 there, center at 0, center of the circle. So it's not that basic circle, a unit circle. Now, what's going to happen as I go through from left to right, or they call it counterclockwise. We're going to start here and start moving in this direction around to complete the circle. As I do, I'm going to identify the beginning here as 0 degrees. By the time I move, and it's moving from here, they call this the initial side of the angle, and this is my final side here on this. And as I move counterclockwise, guys, it's going to sweep out along the circle and then we'll call this the terminal side. The initial side, the terminal side. Now, can someone please tell me, if I sweep out that much of the circle, by the time I reach this point here, I'm representing how many degrees? How many degrees have I actually swept out? 90 degrees. If I should now pick up and move counterclockwise, like I'm moving in this direction, further, and sweep out this circle, and stop there, how much in terms of degrees have I swept out? 180, half the circle. And if I continue, which I'm supposed to sweep out, and I'll continue in this direction, counterclockwise, 270, represents 270 degrees. And finally, yes, when I finally sweep out this last arc, absolutely, so we put a comma here, so this could also represent 360 degrees. That's basically what it comes down to in chapter 5. You have a unit circle, you're sweeping out arcs on that circle, and everything's in terms of degrees, which makes sense. Now for us though, and when you move into these upper division courses, they want us to identify these numbers, 0, 360, 90, 180, 270, they're in degrees now. They want us to place it in another measure. And that's what I had a discussion on, short discussion, last week. They want us to convert to radian measure. And if I hear that word radian, I hear radius, so it has something to do here with the circle. Guys, radian measure, here we go. I'm going to remind you, if I start at 0, I'm going to go back to 0 degrees, which is also 360. And I say, now can you tell me in terms of a radian, how much of the circle have I cut out exactly at this point? You would say, Professor, none. So this could be also represented as, I'll put it in red, 0 radians. I'm not going to use that superscript of an R there, it's understood being there. 0 radians. By the time I reach 90 degrees, that's in degrees now, from middle school, but now how much of the circle have I swept out? And I can rename this 90 degrees in a different measure, something else. And that was the discussion we had last week. I think I've cut out, what, 1/4 of the circle to form 90 degrees. And by the way, guys, the entire circle has a measure of what?
360.
360 for degrees. And what's the circumference of the entire circle as I sweep it out?
2 pi r.
Yes, 2 pi r. Of course, my r, think of this as 1, the unit circle, which is the easiest in the world. So my full circumference is 2 pi. If you look at 90 degrees, the way I formed it from the initial to the terminal, I went this way, in this direction, and cut out 1/4 of the circle. So let's take 90 degrees and show that it can be represented as 1/4 of the full circle, which is 2 pi. Then we end up with pi over 2. And that's what now we will represent 90 degrees as pi over 2. Just a different way to measure. By the way, that is 3.14 divided by 2. That's roughly 1.57. So if I say, what angle are you thinking about when you think of an angle of roughly 1.57? You've got to think in your head, he's talking about a 90 degree angle. That's just in a different measure. My 180 here, I'd like to convert this into this new measure of radians. By the way, guys, I go back to the initial always and sweep out, as I did, half the circle, then I can convert real quickly 180, should be 1/2 of the circle, which is 2 pi for a circumference. And that's why we get to name this as pi in this new measure, radian measure. And that is 3.14. 270, if I sweep out from the initial side, turn all the way around, and sweep out the circle, guys, I think I've swept out, what, 3/4 of the circle? Okay, so I'm going to try to do that and change 270. So 270 in this new measure, I've cut out 3/4 of the circle, and the full circle again is 2 pi. Clean that up, guys, I think it's 3 pi over 2. That's all this comes down to. So this now is 3 pi over 2. And finally, if I start from the beginning here, sweep out the entire circle, I'm back at 360. I'd like to convert 360 into this new measure. Well, this is probably one of the easiest because you swept out the entire circle, which has a circumference of 2 pi. So this now can be represented as 2 pi. Just different ways to measure what's going on in the circle. Now, the interesting thing is, and why I do all this, in calculus, if they're doing a calc procedure and all of a sudden they're saying the angle has a size of 3, they don't say 3 degrees. They don't say 3, but it's understood to be 3 radians. It's just a number, no degree mark, just 3 radians in this new measure. Guys, 3 has an angle of size 3, and let me label it as I'm doing this right now as I think about it. On this grid, to locate it, we've got a quadrant 1, a quadrant 2, a quadrant 3, and a quadrant 4. Can anyone tell me, if I ask you to tell me which of the 4 quadrants with an angle of size 3 fall? I see a hand going already. Quadrant 1, quadrant 2, quadrant 3, or quadrant 4. Where is it if I say it has a measure of, and 3 is a small number, but it has a measure of 3 radians? Go for it.
The 4.
Okay, I heard 4, okay? Yes?
3 radians would be in quadrant 2.
Quadrant 2. Now why quadrant 2? Because you're caught between, if I say 3, you're caught between pi over 2, let me do this for pi over 2. That's pi, 3.14. Divided by 2, guys, that's roughly 1.57. If you do the math here. Pi, my goodness, that's approximately what, 3.14? So if I say, where's an angle of size 3 located? Is it caught between 1.57 and 3.14? So I'm in quadrant 2. Now, just in degrees, you're caught between 90 and 180. And now I'm saying, now you have a measure of, in this new measure of 3 is caught in quadrant 2. Let's try another one. I'm thinking of an angle of size 5. 5 radians. Based on what you see here, which of the 4 quadrants with an angle of size 5, where might it fall?
4.
I heard 4th.
2.
Okay, and I heard 2. 5 now? I said 5? 5 radians.
3, 4.
Okay, now let's help you out here. I did not estimate 3 pi over 2. 3 times 3.114 divided by 2. I think it's roughly 4.71. You guys can check me out later. So I got 4.71. I got 3.14, if I actually calculate the numbers. This is 2 times 3.14. This is roughly 6.28 if I need it. If I like to estimate it. Now, I said an angle of size, what number did I use?
You said 5.
5? So where is 5 located? Is it caught between 4.71 and 6.25? Am I in quadrant 4? Who on earth would think you're in quadrant 4 with a measure of 5? I'm talking about 5 radians, not 5 degrees. 5 radians. And therefore you just have to locate, tell me which quadrant that angle is located. Now that's the basis of this, guys. On the side here, I do want to point out before I jump into some nice stuff here. If they ask us to change from one to the other, 1 degree measure, degrees to radians or vice versa, they have, your textbook has, which I think was nice, they give you what they call conversion factors. How can I convert real quickly from one to the other and not necessarily have to draw a unit circle and trace like I did here, which really, that's what it means. Guys, they love to use this letter from the Greek alphabet, theta, to represent an angle in trig. They just love that letter for some reason. It comes from the Greek alphabet, theta. And I'm putting it in degrees. Now, for some reason, I would like to change that into radians and not go through this business and discuss it each time. Just quickly change it into this new measure called radians. Here's my conversion factor. You take that angle in degrees given to you and merely multiply it by pi over 180. And that will quickly change that angle theta into, now I'm going to use a superscript of an R, into radians. If vice versa, they give you the angle in radians to begin with, theta is in radians, as right now, and you will go backwards and see how many degrees was that.
180 over 5.
Yeah, the conversion factor is flipped. It's 180 over pi. And that will quickly change that into, now the angle is in terms of degrees, written like that. So that would save you from going through all this discussion each time. They call them conversion factors. Let me make use of those right quickly, guys. Let's say theta as a measure of 12 degrees. And I do not want to go back here and trace 12 degrees and all that business. I'd like to quickly change it into this new measure, radians. That's in degrees, that's 12 degrees, times, my conversion factor is pi over 180. I'd like to convert it quickly. Now we'll do some arithmetic, fractions. I think 12 goes into, someone help me out, I think it goes into 180 evenly, exactly, about 15 times. I did that quickly. Is it 15? So this is merely pi over 15.
15.
Does 12 go into 180 15 times? Does it? Is it 115?
Yes.
Yeah. So pi over 15. Now, talking about strange, I did my conversion. I'm talking about now pi over 15. You're saying, my goodness, now which quadrant is pi over 15 located? Well, I know it's 15 degrees, so I'm like in quadrant 1. That's a small angle, but now it looks like that in my new measure here. And all they did in your textbook was to make this a little bit quicker. They gave you some conversion factors to use. Let's try another one here. Let's say theta was given to me to begin with as this, no degrees, no degree mark, radians. It's called 2 pi over 3. Radians. I'd like to know, what are they talking about? What angle is it? Let's convert it to degrees. If it's in radians, here's my conversion. We're going to take that 2 pi over 3 times, the conversion factor this time is 180 over pi. Easily done. Pi's will cancel. I think 3 goes into 180, 60. 2 times 60 gives me what, 120?
Yeah.
Now 2 pi over 3 is the same as a 120 degree angle. If I say 120 degree angle, everyone can locate it. Where is 120 degrees located? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. It's quadrant 2, isn't it? It's called between 90 and 180. All we're doing is calling these conversion factors to save you from drawing that unit circle each time. Answer this, go for it.
Where'd you get the 180 over pi?
That's given to you. That's a factor. It's like a formula. You have to memorize those. You have to remember which goes where. Those are given to you. Those are factors. Yeah.
Yeah, you wrote down for estimated value 6.28, what this stands for?
That 6.28 is merely 2 times 3.4,
It's 2 pi.
3.14. Pi is 3.14.
Ah,
So if you multiply by 2, I think 6.28. If that would help you. It's roughly 6.28. Okay, guys? Are you with me on this? Can't go wrong here. Cannot go wrong. Unless, let's say the next one looks like this. Theta is 1. Say approximated is 1. Notice I did not use a degree mark. I'm not talking about 1 degree, I'm talking about what, 1 radian. Now you'd like to convert it back to degrees to make more sense of it. Okay, guys, since it's in radians, let's take that 1 and multiply it by, here's my conversion factor, by 180 over pi. Mr. Park, you may have to help me out this one. Can you take 180 and divide it by pi real quickly for me, see what that is? What's that close to?
57.29.
57.29 degrees. Are you kidding? Walk up to you on campus and I just saw one of my former students as we came to class tonight. Can you imagine if I had stopped you out there and said, I'm thinking of an angle of size 1. Where is it? And what does it look like? And he would say right quickly, 57.29 degrees, Professor. That's in quadrant 1. 1? We're talking about 1 radian, not 1 degree. 1 radian is roughly 57.29 in this unit of measure. Yes, before.
So how do you know when you're gonna use whether it's pi over 180?
Beautiful question. Pretty soon you're going to start using just the radians. They're going to get away from degrees. They're going to get away from degrees until you cross the street to the middle school. If you want to go back and look at degrees. We prefer to work with the radian. And by the way, guys, when I say radian, you're talking about just a number. You don't have to put a mark there. You don't have to put that little circle and say this is degrees. It's not degrees. It's just a number that represents those degrees. This is a new way to measure. Before I leave it, a good question she gave me. Guys, 12 degrees. Hang on a second, 1 second. 12 degrees. I know where it is. You know where it is. Before I leave this. 12 degrees is right. Let's say it's in here. Let me mark it right here. Let me erase this. She just made me think about something and put this right here. That's 12 degrees. Small angle. Here's the initial side, the terminal sides are red, caught between, I formed an angle. Looks like an angle. And it's a small angle, 12 degrees. Can anyone tell me, be clever, we converted it to radians and got that. Can anyone tell me what that pi over 15 represents? Anyone? Yes.
So, basically half of the circle is gonna be pi, and so pi over 15 means that half of the 360 is gonna be divided into 15 slots, and that's one of the 15.
I like that. Something a little bit better to reflect what all this is about. I know what you're saying is good. Yes, Samantha.
Pi over 180 is a conversion factor, so they equal the same thing. So in order to convert, for example, degrees to radians, you can use that as a conversion factor in order to convert it to radians. And same goes with if you're given radians to go from radians to degrees, because 180 over pi is still equal to the same thing. Your product is gonna be like in degrees, so they cancel out the pi's.
They could. I followed your discussion. I followed it. I followed your discussion also. Here's what really, truly, with what we're discussing here, means. Now look at this. You wouldn't believe this. Mr. Park, could you take pi divided by 15 and approximate what that pi divided by 15, that's a number. What's that close to?
0.209.
209.
Yeah.
Guess what 0.209, which is pi over 15? Here's what it is. I heard the other discussion. It's the length of that arc. It's the length of that arc that angle cut out. So if I had a perfect unit circle and a pair of scissors, and I cut it here, and I went up here and cut it here, that little arc, then straightened it out and took a ruler and measured, guarantee you, you measure that strip, the little arc, it's roughly, as he gave it to me, it's roughly 0.209 centimeters, or inches, whatever units were. That's what that 0.29, well, that's what that pi over 15 is representing. It's representing the length of the arc that pi over 15 cut out. And before I leave it, before I get to you, Pi over 2 is roughly 1.57. Let me go back since I'm talking about this. Pi over 2 was this arc. Here's another example. Divergence 90 degrees. And what does that also represent? If I took a pair of scissors, I'd clip it here, bring it out, straighten that arc out, measure it with a ruler, roughly 1.57 centimeters.
This,
Roughly 1.57 inches if you're using the units to be inches. That's the length of the arc. That's what radians is all about. It's the length of that arc. So pi over 2 in radian measure. That's all we're doing there. Samantha.
You previously asked a question about the quadrant. It was for 5 pi, yeah? I don't entirely understand how it goes. You said in the 4th quadrant?
Now, which one was it now?
It was 5 pi, I think.
It was just.
Oh, 5.
Oh, was it?
I thought you said 5 pi, okay.
Oh, it's different,
Five.
yeah. Different.
Okay.
So guys, that's the connection right there. If you just get your mind to start thinking about not the middle school degrees, start thinking about how much of, what's the length of the arc that angle cuts out. Those kids across the street are not thinking like that. They're taking those protractors. We're not doing protractors. That's what they're using to get degrees. Now, we're interested in more of not the degrees, not the protractors, and line the protractors up correctly. I'm interested in how much of the circle does it cut out. That's radians. What's the length of that arc it cuts out? I know it's 90 degrees. But how much of the circle has it cut out? And that's called radian measure. Okay, I gotta move on. Yes.
does it mean so, pi over 15 is just the ratio of the terminal and?
No, we're not gonna go there. No. We're just trying to make all the connections here and here together. That's all we're doing, just making connections. Guys, that make more sense now? Now, if I said I'm thinking of an angle of roughly 6.28, and I don't say degrees, I'm thinking of an angle whose measure is roughly 6.28. Can anyone tell me the size of that angle? Yes. 360.
Or 0?
No, zero. Zero has nothing. It's 360. You have to cut out the entire circle. That's what they cut. Move of 360 degrees. That's 6.28. Who would think that? And that's the way mathematicians think. They will think in radians. They can do more with it in radians than degrees. Okay? So that's all that's going on here. Now, with all that said, though, here we go. Right here, part 2. See if I'm ready for this. I think I am. This discussion we had here. I did this. Let's see if I'm ready. Oh, I am ready. This is going to be fun here. Now, we'll give you the definitions. You say, oh no, here goes definitions. They call them 6 trig ratios. Okay, so 6 trigonometric functions. Everything's functions in this class. Watch carefully. You're going to appreciate this. These are the most brief definitions you'll ever see. I don't care what grad school you go to. These coming up are definitions, are the most basic definitions that you will ever see. And they're given a name. First one. The name of the function is spelled this way. Sine. S-I-N-E. It has something to do with this unit circle. Function's called sine. It's abbreviated S-I-N. And of course, an angle, theta. That's its abbreviation, S-I-N, theta. Then would you find this function, sine theta? But finding out I need this definition, what do you ask me to find, Professor? Here's the definition. You're going to appreciate this. Definition of why. Now, before I mention the others, here goes. Anyone real quickly tell me, since I had that unit circle staring at me, at 90 degrees, here goes. I'm going to do it for the whole circle. Can anyone tell me the ordered pair ordered pair, which I don't have listed up there yet. And by the time you sweep out, you reach 90 degrees. I know it's pi over 2 in this new measurement. I converted it. But can anyone tell me what coordinates does that point right there have?
1, 0,
0, 1.
0.
That's across the street. 0, 1. Now, since I did it there, I needed also to complete these definitions. Let's do it on all my major critical numbers. Here, the very beginning of the unit circle, if I say coordinates, like on the grid, I would hope you say 1, 0. As a unit circle of 1. Over here, at 180, I would hope you would say negative 1, 0. On the grid. Finally, 270, 0, negative 1. Now I know x and the y for each one of these major angles to work with on this unit circle. That true, guys? Yeah. I've labeled them from the grid. Now, can someone real quickly tell me, here's my first definition, sine of an angle, its definition is y. Suppose I ask you what is the sine of, here's an example, the sine of pi over 2, which is 90 degrees. I'm asking for the y coordinate at pi over 2, and here's pi over 2 right here. What was the y coordinate up there? 1. So the sine of 90 degrees, sine of pi over 2, is merely by definition 1. Mr. Park can use a calculator, you can use a calculator. Press your sine key, put in 90 degrees, you're going to get a 1. That's where it came from. Another definition. Cosine, spelled this way. Abbreviated this way. COS. Cosine. Definition, one of the easiest ever. X. Just look for the X. Now, if I ask you for an example here, let's try cosine. C-O-S. Let me choose one of those I had marked already for us. Let's try 270, which is 3 pi over 2. Let's find the cosine of 3 pi over 2. You'll say, Professor, right here's 3 pi over 2. You've already done it for 270. That's in radian measure. And you might mark the point there. Guys, what was the x coordinate? 0. That's the cosine of 270. That's exactly what your calculator will show. On the screen, 0. That's where it came from. Number 3, 60. Tangent. Abbreviated, TAN. Theta. Definition. Y over X. That's the definition of this next trig function called tangent, TAN. For an example, if I ask you to find the tan of, here we go, the tan of pi. Well, pi was over here, discussed it earlier. And guys, what was the, I need y over the x. Well, the y was 0, I think. Well,
Yes, 0.
and the x was negative 1. So replacing 0 over negative 1, which is going to give me an answer, of course, of 0. You're done. How can you go wrong? Hang on. Now, I'm gonna take a question. Hang on. I think it might tie in with what we'll do right now. Suppose I ask you to find the tan of 3 pi over 2, which I tried earlier for cosine. Well, you said, Professor, the definition of y over x, 3 pi over 2 is down here. I marked everything for you. Ordered pair. You place y over x down here. You place a negative 1, that's the y, over 0, the x. And this is the first one you've seen here on this, where it's undefined. There's no answer. No answer. Now I'm taking that question. Is that what you sort of had in mind? Or what do you have in mind?
I just wanted to ask if this was a prerequisite for the course.
Of course.
No, I just gotta remember it.
You gotta memorize it. I use that word memorize in math, but you gotta memorize it. Now, I don't think I could not find anything easier to memorize than a y, an x, a y over an x. We're not saying a definition with words, just basic letters. Okay, number 4. Next one I will mention is the spelling looks like this. Secant. Abbreviate S-E-C theta. Secant. Another trig function you gotta know. Definition? Let me put the definition on here. Definition. 1 over x. Secant. Abbreviated S-E-C. Now we're gonna try one on one of these. Secant. Guys, let's try secant of 0. Here's 0. That's the beginning of the unit circle. The ordered pair, I think we listed as 1, 0. I need secant, which is 1 over the x. Is the x 1 there? So it's merely 1 over 1 by definition. So secant of 0 is 1. Done. Can't go wrong. We'll try one more before I leave this one. Secant of pi over 2. I've marked pi over 2 for you earlier. It's up here. I need 1 over x, and x in this case is 0. So I got what? 1 over 0, which I think gives me an undefined, no answer. And that's the secant. Number 5, cosecant. Comes this way. Abbreviated CSC theta. Cosecant. Definition, 1 over y. Now if I trust that definition, I hope all these definitions are correct here. And now let's, for an example, let's try to find cosecant. Guys, let's try maybe cosecant of pi. And I have pi over in this unit circle. I've got it in the unit circle. It's back here. Cosecant should be 1 over y, but the y is what there? Is it 0 for pi? So I got 1 over 0, and darn it, I run into another undefined. Can't do it. Let's try to find one we could do. Let's try to find cosecant of 3 pi over 2. 1 over y for cosecant. 3 pi over 2 was down here. I have marked for you. The ordered pair was 0, -1. And I'm placing 1 over y. The y there is what? -1. So it's 1 over -1. Final answer? -1. Done. That's an answer. Last one, David.
Cotangent.
Cotangent.
That means x over y.
Hang on now. Cotangent, abbreviated, I can use this abbreviation. COT, cotangent, and he's right, give me the definition, he says, Professor, this one's x over y. Guys, we'll just try one here right quickly. So they asked me to find the trig function cotangent, COT, and they got to tell me what angle they want me to find the cotangent of. Let me try one, let's try 0. And guys, the cotangent of 0. 0 is the beginning of the unit circle. Now here it is. Ordered pair was 1, 0. I'm looking for cotangent, which is what? 1 over, or x over y. Was that 1 over 0? Down here, we're going to another undefined, which could happen. Those are your 6 trig functions. Go on to Harvard. Travel to NYU. Go to where Maya is, so she finished up at UCLA. Are these what changed? No. I don't care which math course you take and where you take it. These trig functions are given. They'll never change. Look how basic those definitions are. That's what require you to remember, I use the word memorize, but you gotta know, remember those basic definitions. Now, you know me, I see the time's gonna be for a break here shortly. I lost a little bit of time with Maya. Now, you know how I do this. I usually throw it out and say, well, if someone can get this, your exam from the exam on Wednesday. I like to say that's just to challenge you. We have the definitions. Here goes. I'd like to find the exact answer for, here goes. I'm gonna try cosine. And I'm gonna try this. I tried sine of pi over 2, I tried cosine 3 pi over 2, I tried some, you saw what I was doing over there. Now I'm trying to find cosine pi over 6. Now hang on. Pi over 6. Now I see my students, I see their eyes. They're looking at the professor, I'm looking at that circle. I don't see a pi over 6.
It's between.
No, I don't see a pi over 6. Therefore, you cannot tell me what it is until you come up with, not only where pi over 6 is, I think if you convert it right quickly, we're talking about 30 degrees.
Yeah.
I didn't mark it for you. So before we take a break here, if I should mark it, let's say 30 degrees is somewhere, something like this. Let me erase this one, guys. I was referring to 12 degrees there. Let's say now my angle from the initial to the terminal, this angle is representing 30 degrees. That's pi over 6. If I convert it, that's 30 degrees, pi over 6. I don't know what the cosine is. That means I'm looking for the x coordinate. Cosine definition is x. I'm looking for the x at 30 degrees. But wait, Professor, you gave it here. You gave the order pair here. You gave it here, you gave it here. You gave it to me on the others, but you did not, Professor, give me the x and y coordinate for 30 degrees. And you cannot answer that question until you tell me a way, and oh, this is beautiful, a way to come up with what are the coordinates, the x and y, at 30 degrees, which is pi over 6. And I did not give them to you. I see some hands going up, I'm gonna take some thoughts. It's a good way to take a break here shortly. Let's start by here, Sarah.
Okay, so we're looking at cosine, we said, is the x.
Hang on now.
Cosine, we're looking at
That's the
x.
first thing she says, Professor, the definition is x, I'm looking for the x coordinate,
And the x coordinate
I'm looking for
is,
that right there.
yeah, the x coordinate is that, the x, on the x axis.
Okay,
If
that's
we're,
all.
okay,
Okay, you, go ahead.
wait, can I keep going?
No, you're right.
Okay,
It's along the x-axis.
yeah, and then our radius here is 1.
It is.
So that line connecting to the, well, basically both lines are, the line connecting connecting to the,
Here, my dear, come here, show me what
Okay.
line you're talking about.
okay, this line is 1, right here.
It is one.
Yeah, but we are looking for,
Oh,
and there's a formula,
nice.
and this is gonna,
Now, step back. She is on it. Look at it. She says, wait, Professor, we're being clever. She says, I know this is 1. Because that's the radius of the circle. And this is that unit circle. No matter where you draw a radius, it's 1. There's 1 down here, it's 1 there, it's 1 here, it's 1 here. Draw a radius, it's 1. So she says, that's 1. Then she's being extra clever, which I love. She says, wait, Professor, could I do this? Could I drop a perpendicular down to the x-axis and form a small right triangle? Now, let me remind you from across the street. This side, the side that she placed the 1 on is called the hypotenuse.
Yeah.
It's the side opposite the right angle. It's 1, it's because it's on a unit circle. That's one. The other two parts are missing, and I need those other two parts so I can name the coordinates. Now, she's saying, Professor, I know this represents the x that you're looking for, it's right here. And this represents the y, let's squeeze it in. Let me circle. She says, if I can come up with some way from maybe middle school, what x and y are on that triangle, and inside here is 30 degrees. By the way, guys, if it's 30 degrees, it's a right triangle, must this one up here in the corner be 60? Is it a 30, 60 right triangle?
Yes.
So that angle right there is 60 degrees. It's a 30, 60 right triangle. Some students may remember something special about a 30, 60 right triangle from trig. Others may take a little time to figure it out. And after you figure it out, you'll be able to list that x and y for me, and then I can answer this question before we take a break. Does anyone have an idea, or does anyone remember there's something special about 30, 60 right triangle from the basic geometry course? There, that works.
One side is it's gonna be 2x, x, and then x squared. X to the x times
Look at this, look at this. Guys, this is what she's telling me. She's saying, Professor, if you draw a 30, 60 right triangle, I don't care how small it is, I could enlarge it, make it this large, and still have a 30, 60 angle in there, and make it a right triangle. She said, no matter how large the triangle is, how small it is, they have something in common. I like to think of it like this. She's thinking of it the same way. The side opposite to 30, that red side for me, that red side, is always, no matter how large the triangle is, how small it is, it's always in terms of length, the side opposite to 30, 1/2 the length of the hypotenuse. And my hypotenuse is set at 1. So this side must be automatically what? 1/2. 1/2 of 1. Let me circle it. That's the best part of that 30, 60 right triangle. The side opposite to 30 is always, for its length, 1/2 the length of the hypotenuse. I have one remaining side to find, and I hear some students tell me what it is right now, but let's say you did not know what it is. Can anyone tell me, being clever, on this triangle, right here, this triangle here, the red side, the orange, I guess, brown, and the black, those are the sides. On a 30, 60 right triangle, this is 1 here for the hypotenuse, this side is 1/2 always. I'm looking for the side down here. Does anyone remember anything I could do from middle school to find the last side of that triangle, which I have identified as x? Now, since the hand's going up, let's go here first.
Would it be a squared plus b squared?
C squared is equal to a squared plus b squared, which was known as back then the Pythagorean theorem. We got c squared equal to a squared plus b squared. He is correct. And in that Pythagorean theorem, the c was representing the hypotenuse. But my hypotenuse is 1. I got 1 squared. Guys, you will represent this as a in the Pythagorean theorem, I call it x. You say that's x squared. It's unknown. B, the other side, this side, is 1/2 squared. And there's c squared is equal to a squared plus b squared. Now I'm going to solve it right quickly. I'm going to solve that equation for x. 1 is equal to x squared plus 1/4. Move that 1/4 over, 1 to 3/4. Easily done. Take a square root. And guys, the square root of that's going to be radical 3 over 2. Hang on. That's the x. I did it quick. I just solved for x. Radical 3 over 2. That goes right here. Now I know what the x is. On this particular 30, 60 right triangle, this x down here is radical 3 over 2. And therefore now I know what the coordinates are. This is 1/2. And this is radical 3 over 2. With a little thought about 30, 60 right triangle. Now can I answer the question? Well, the cosine's definition says I'm thinking with the x. What did the x finally come up to be? Radical 3 over 2, and that's the answer. We'll try one more, then we'll take a break here. I want tangent this time. Let's take tan of pi over 6. By the way, as I do these, I would hope that everyone in class would say, Professor, I would prefer to do this any day rather than a logarithm.
Yeah.
Unless I may have a few students who like logarithms that much. But I think myself, I would rather do this than logs. Hang on just one second. Tangent, definition was, let me find tangent, y over x, it's in red. 5 and 6, thank goodness now I have something to work with. 5 and 6, we decided these are the coordinates. So we need to place 1/2 y over radical 3 over 2. And if I clean that up, and I'm careful, the 2's are going to cancel, for sure.
Yeah.
And I cannot leave that radical in the denominator, I gotta rationalize. What was that going to look like if I rationalize? Yes?
Root 3 multiplied by
Root 3 over?
over
Over 3. Radical 3 over 3. And that's the exact value for tan of 30 degrees. Tan of pi over 6. Now, I know it's time. Oh boy, is it time. Hang on a second. Now, I'll stop, give you 1 minute. We'll take a 10-minute break. You know and I know. When I pass out these review sheets to you, some students always ask, Professor, are these, that's what I see on these review sheets? Is that the way the test is gonna look? I'm giving you examples to look at and think about. I'm not giving you the test. Would you like for me to pass the test out maybe a week before the test takes place? We had one professor here one time that did that. Didn't stay very long with us, but they did that. They passed out the test. They passed out the test. They had it for a week, and you came in, and your test, you opened the test up, same test. Am I gonna do that? No. No. I'm gonna put similar problems. Now, look at this. Why not? I like to find the log. Base 2. Why not? Then we'll take a break.
So that would be a log 360.
And here's a math course. One of these students are doing so well through other schools. Guys, can anyone remind me what sine is y? It was 1/2. Back here, 5 and 6 right done. Y is 1/2. Hang on. Put this together. 1/2. That's trig. What do you see your final exam? And now I have on the outside though, I gotta find log base 2 of 1/2. Can anyone tell me what you think the final answer is? -1. Aiden and I were discussing something like this in the office. Why is it -1? Because that statement right there tells me, or says, base 2 raised to a -1 is 1/2. That is the same as this. Guys, you need a good 10-minute break. Oh, good. You got 10 minutes. Good break.